Hey, welcome back. Last time we spoke about Wi-Fi for our Pico W, and this time it's getting more interesting, I think, because we will connect to our MQTT message broker. Let's start straight away. Okay, last time we stopped here, so we did set up the wireless infrastructure. You need to do this as well. We need it now, so please do it. Watch part 1 if you didn't do so far. Now we will go to manage packages. We need to install the package manager, in this case for MicroPython or for the microcontroller, so UPIP. Look for UPIP and you will find MicroPython UPIP here, and you need to install this package because we need the MQTT libraries, and unfortunately we can't install, if you look for the MQTT, so the micro MQTT libraries, you will find them here as well, simple and robust, but you're not able to install them from the package manager. You can try, you will get an error message. So we need to install them from the shell itself using the library we installed, the pip library for the package manager. Okay, so if the package manager is installed, we start the code, so our code for the wireless connection. Now this is important that wireless is connected. Now we can import the library from UPIP. Okay, and if this is done, we can use it to install something. So we use the install class here and we install MicroPython MQTT. We will take robust and simple, and this is now installed to the library directory and also simple. Okay, so both is installed. You should see in the libraries directory now the py files for UPIP and also UMQTT, robust and simple. Okay, if this did work, we are ready now to connect to MQTT. Alright, I did rename already my file because this is the file I will publish on GitHub for you. And now we want to set up our MQTT server. First of all, we need some libraries. The first library we need is the MQTT simple, and we take the client because we just need a client now. So because we just want to have one, we need from and not import, and we import the MQTT client library. Okay, second thing we need is a server. So we need to define a server. I call this now MQTT server, and now you need a server which is existing on your system. I did this in a video already, and I will set a link in the description and maybe on the video here itself. So we won't do this here. I have a Mosquito server running on a Raspberry 4, and this is the address of the Raspberry 4 and the Mosquito server. Yeah, we can take a look how to check it, but we will not install it today because we did it in another video already. So I opened my Raspberry 4 just to show you. On this one I have a Mosquito server running. So I see here the Mosquito information. And let's publish, for testing, we will publish a topic, and we can set this later on, and maybe this is, I call this a real test maybe, and we simply take surreal. Okay, so when I publish it, it's there, but it's gone. So we will do this again in a second. But first of all, let's connect to the server. Okay, we will create a own function, a new function, which we will use for our connection part. So we define an MQTT connect function. This will be our client to connect to our broker. So we need to define the client. Let's call this client, and we take the MQTT client from our library, which we imported. And we need to define a client ID. You can take any here. This is just for the identification. And I take the real Pico W. And afterwards, you need to define your server. We had a address here on top, so I take the address which we defined. And you need to take the port. I have the default port 1883 and user none, in this case password as well, because I have no, so anonymous login is set. And that's why I also can set SSL to false. And by the way, keep alive. You can play with that, but 3600 is quite common. Let's start the connect. Client connect is the command. And let's test it. And we don't get an error. That's good. Okay, we want to subscribe to our topics. I will set a topic here as a variable. Maybe that's easier. So I call this topic test in this case. And you have to set it as a binary. And how did I call it now? Let's go back. I said surreal test. Okay, surreal test. So that's a topic we want to subscribe to now. Okay. Okay, we can now subscribe to our topic. That is called client subscribe. And we had the topic test. That is what we defined here, topic test. And now we are subscribed. However, if we receive a message, then, and this would now happen when we wait for a message. So the next thing would be client wait for message. If this happens now, it will wait for message. And if it finds a message for this topic, you can subscribe to several topics, it will call the callback routine, but we didn't define it. So we need a callback routine. We can call it callback or anything. Other name is okay. Maybe we just say print message received. And we have to define that this is the callback function because we can use any here. So we have to set the callback function, and this is called callback in this case. So let's see if we have an error somewhere. No, it did start, and you see that it didn't leave the shell so far, or is not back. It didn't exit the code because it's now waiting here for the message. So let's see what happens if we send a message. We get an error. Okay. And the error is quite simple in this case because the callback will get the message as an attribute. And what we didn't do so far is that we set the two variables which the callback function will get. So let's do this now, topic and message. And maybe we print the message here directly as well, just to show that this is working. Okay, stop, and again. So we have now topic and message, both is existing. We do it again, and you see that a message is received and we get a binary surreal. So you see that we also need to decode the message, and it depends a little bit what format it is. If it's a JSON, it's a different decoding, and we will have JSON later, so that's why we need also other libraries, but let's come to that in a second. Okay, last thing we want to do with this test setup is to decode the message once, even if this is not a JSON, but just that you see how this is working. So there is a method existing for the message. You can just say decode, and UTF-8 is the format we want. And that's already all. When we now start it again and we send the message again, we get a surreal without the binary, so it's decoded. The next thing I also want to change is that the wait is in the connect routine, because I just want to start this once. It's just the connection. We will do the subscription here, but I want to have the wait here. Usually, because this is not a global variable, this might cause an error. However, we don't need a global variable. In this case, we can simply call the MQTT connect routine and set the client as our variable here in our main function. Of course, in this case, we need a return. So we need to return the client. So if we call now MQTT connect, it will return the client, and the client is addressed to client, so I can call it afterwards. Let's try this. And it works. So we are more or less ready now, so we can deal with MQTT brokers and we can grab some data. Let's take a look at Node-RED. In several tutorials, I created different Node-RED things, let's say, and I had my BME to 180 sensors, for example. In another one, I had from OpenWeather the API information about weather data. And I also have some other sources, let's say. So we can take these information and bring them to our MQTT broker. So you see this is an MQTT out node. And with this node, when I configure a server, I can create some information and we will give it a try. So let's create MQTT out just that we can see how this is working. You need to take a server. I did define my Raspberry 4 already, so my Mosquito server. And you see I have localhost because my Node-RED is running already on my Raspberry. Otherwise, you need the IP here. Default port, we had this. I have anonymous login, so it's quite easy in this case. And it's okay. And I can define a topic. In this case, we had, I think, the real topic and maybe test in this case, or we put subtopics via our messages, but let's take this one for our first try. And now it's pretty easy. We can simply take a node, connect it, deploy. We go back to Thonny. We start our routine. It is still waiting, in this case, for my topic test, serial test. And I simply send a timestamp to my serial test MQT out. And you see I received a message. I can do, I just wanted to restart. Okay. I can do some other things as well. I could put some, I don't know, string in and serial goes MQTT, and let's just deploy it and send it, and you see the message goes through. Of course, you can also do this regularly, let's say every second. And let's also change our program code here, and let's go for the wait into a while loop. If you take one or true, whatever you prefer. And let's start. And you see that we get the message all day long. So the last thing for today is we want to use some JSON-based information. I have this JSON object here. This is information from the OpenWeather server. And you see I have here some information about sunrise, sunset, temperature, and so on. I have, as I said, several sources, but we need something to play with, which you can all access, and OpenWeather everybody can access for free, at least I think 60 calls per day or something like that. I have a video somewhere on my channel how to create the API access to OpenWeather maps, which you can see here. So I will not describe this now, just now going into details about getting this data to MQTT, which is quite easy. You just simply place the MQTT node here, you set your message broker, and then we just need the other side. We need our good old Thonny, and we change our topic. I will call this now topic A. And it is not serial test anymore. It is now weather, because that's what the weather node sends. Oh, I have now two B's, so weather. And because I said topic A, I also have to change this one to topic A. And let's first take a look what will come. We start this one. Okay, working, waiting. We go back and I just initiate calling the data. And you see I get an object. And this is a quite long object because this is now a JSON object. And to decode this, we will add another library. And this is the JSON library, which we will use to decode the JSON information. For that, we need to change the callback routine. So here our message received, and then we have printed the message. We will now, let's create a variable. Let's say our message here inside, or let's call this JSON message is from this point on, and now we use a JSON method of the library we have imported, which is called loads, and we decode our message again, which we did before as well. So that's something we have to do anyway. So the decode of our, we should have kept this anyway. So UTF-8. So that's the first thing we do, but we also use the JSON loads here, and now we can take some, or maybe we take first a look what happened, and we just print our JSON message so that you can see what happened after using the JSON loads command. Let's start, and let's start this one again. And you see that it already changed a little bit, yeah. So maybe you can't see this from the shell now because it's still looking like before, but now it is a JSON we can handle in MicroPython, and that's important. And we can see this when we continue now, because we have now the chance to take specific objects, let's say, yeah. So it's now your choice what you want. I completely remove now the JSON print so that we are not getting confused, and we just take from the JSON itself some specific elements, and you can do this like an array, can access it like an array. So what do we take? Let's take, I don't know, let's take wind speed first. So we want to have wind speed, and the only thing which we need is now the JSON message, and we need current. Why current? Because this is the top line. Maybe it's easier to show you this in Node-RED. So when you take a look at Node-RED and these objects, then you see it's an object, and if you open it, there are several on the root level, and then there's current, and on current we find somewhere wind gust and wind speed. So going back to Thonny, we can now use current, and from current we use now, for example, wind speed. You have to deal with this a little bit because I like this in knots, and this would be now, oh, I just simply forgot the equal sign. So maybe we do this again step by step so that you can see what I want to do. I print this first. Let's take a look. Let's start again. Okay. And you see now it worked. We just got this specific object. If you want to add some further information, for example, you want to say, hey, that's in knots, then it must be a string. So we have to convert this to a string. That is the first thing. Okay, let's convert this to a string, and then we can add the information knots so that this is now having full text. And by the way, as this is not in knots, we have to multiply this with 1.94. Let's take a look if this worked. We're going back and to Thonny, and we get this in knots. And now you can see you should also have rounding here because it looks a little bit weird. So the next thing would be, and I can only do this before I convert this to a string, I have to round this part here. And maybe if I want to have still the digit here, one digit, I need to multiply this by 10. And after doing the round, I have to divide this by 10. Another try. Back to this one. Start, Thony. And we get the 9.0 knots. So that's how it works, and we can do this with the same method now for several things. We can take the gust, the temperature. Give me a second, I will add a few things. So I did add some additional information from our weather API. I started. I again call some API information, and I had a print of all the variables here, and you can see I have the knots and so on. Of course, you could now make this more in detail and so on, but we want to bring this later to the display, so I don't need the print at all, at least not here. I need it for the display later, so just keep it like this. I also will take some other sources, but this is not a topic of today. I think you understood how to deal with MQTT, how to take the data, and next time we can take a look how we shift this to the display. Okay, I think this was an important step. I hope you could follow the different topics we discussed today. Next time we will use the Pimoroni display to show the data we gained today on the display. I think that's a nice step because it always makes fun to play with displays. So hope you enjoyed it. See you next time. Leave a subscription if you like, and bye bye. See you next time.